Okay, part B of number 5 asks the same thing as part A does, identify what type of conic it is. It's definitely another hyperbola because we have two things being squared. We have the x being squared as well as the y. But we have to do a little bit of reordering in this equation. So I already wrote the equation down for us over here. And what I want to do first is go ahead and group my x's and y's together. I'm also going to go ahead and move this 44 to the other side because we want it, again, to have two fractions being squared, being subtracted from one another, and the other side to equal 1. So I'm going to regroup just like I got done saying. 4 x squared plus minus 8x minus 6y plus 24y equals positive 44 because I'd have to add the 44 to get it onto the other side. From here, I'm going to go ahead and group my x's and y's. And remember, when I put those parentheses around there, it's going to change the signs of what's inside the parentheses. So I need to make sure that I change this term here to a negative. I'm going to continue by setting up my completing the square step. So I'm going to factor out the coefficients of each squared term. Oh, and I forgot the square for the y here. Sorry about that. So again, I'm going to factor out the coefficient for each square term. So this would be 4 x squared minus 2x plus whatever it takes to complete the square minus whatever we added in here. But since what we're adding in there is really being multiplied by 4, we have to multiply the blank by 4. Minus 6 on the outside minus 4y on the inside plus our blank minus, again, whatever we're adding on the inside, but it's being multiplied by 6 equals 44. A little note is that this is really negative 6 times something. So in order to balance it out, we have to multiply positive 6 times something. So make sure you change that sign on the outside. So continuing from here, I want to complete my square. Half of negative 2 is negative 1. Negative 1 squared is positive 1. Half of negative 4 is negative 2. Negative 2 squared is positive 4. So now I go ahead and write it as two completed squares. So basically in factored form, x minus 1, we just take half of this middle number here to get the 1 right there. That whole quantity being squared, minus 6 y minus 2 squared. I'm going to go ahead and combine my like terms, negative 4 and positive 24, to give me a negative 20. Oh, I'm sorry, I misspoke. Positive 20 equals 44. I'm going to subtract 20 from both sides, so I still have all of this same stuff. Now I want my answer to 1 be two fractions on the left-hand side, and also this whole equation has to be equal to 1. So I'm going to divide everything by 24. And 4 divided by 24 is 1/6. minus 6 divided by 24 is 1/4 equals positive 1. So before I identify the vertex or begin to graph this, I want to make a note that, remember, the numbers down here that we use to graph, we don't want to use the 6 and the 4. It's kind of tempting, but we want to use whatever squared equals 6 and whatever squared equals 4 in order to graph our hyperbola. So I want to say, alright, well, what's the square root of 6? Square root of 6 is approximately 2.4. Nothing wrong with a decimal, but we typically don't get that very often. Square root of 4, well, that is a perfect square. That's just 2 squared. So these two numbers are what we're going to use to make the box on our graph after we plot the center point. Okay. So the center point is 1, 2. So I'm going to graph that 1 and positive 2. Then, since this is a parabola that starts, a hyperbola that is in this form with the x coming first, we know that it's going to be opening left and right. So in order to find our vertex from the center, we got to count over 2.4 in each direction. So I'm going to go over 2.4. 1, 2. Make your best guess. 1, 2. Again, make a good guess. So that's where our two vertices are going to be. Now from each one of those, we're going to go up 2 because that's what's underneath of the y. 1, 2. And down 2. Up 2. And then down 2. Okay, so we'll use both of these numbers down here in order to make our box here. So I'm going to go ahead and connect the box, and then we can go ahead and make our diagonals and be done graphing. Okay, so now we have our hyperbolas, and again, here's our two vertices, or our vertex points. So the question still asks us to list out a few things, so I listed out the center. So I'm going to go ahead and list out the focus points next. We get the focus points by doing the Pythagorean theorem. Just bear with me for 1 second. I'm going to use a squared plus b squared, or the 2.4 squared plus the 2 squared. Well, that's really just 6 plus 4, or square root of 10. Because again, remember, we have to use the Pythagorean theorem. 2.4 squared plus 2 squared equals c squared. When we take the square root to figure out what c is, we get the square root of 10, which is approximately equal to 3.2. So we count over from the center 3.2 in each direction, left and right. 1, 2, 3.2. And we go from the center again, left, 1, 2, 3.2. So we got, those are focus points. So just make the best guess that you can. It looks like that this x value right here is about, again, 4.2, and we went up 2. And this point over here is negative 2.2. And it looks like we went up again 2. Okay. And all we have to do last is identify the vertex points. The vertex points are easy to identify. Again, we just count over. They're going to be 3.4 and 2. And negative 1.4 and 2. So now I believe I'm going to scroll back up. We've answered everything. We've graphed it. We stated what the center was, the vertices, the foci, and I remember I did cross out that part in the previous problem about finding the asymptotes. Okay. So let's go ahead and take a look at number 6. Number 6 asks us to solve the oblique triangle ABC. So go ahead and start drawing your triangle as I put this in the right program here. Okay, so like I said, go ahead and draw the triangle, so maybe you're already ahead of me. I'm not going to really worry about drawing this guy to scale. I'm just going to worry about using it for pretty much a diagram. So angle A is 42.3, so I'm going to label everything they give us. Side B is 12.9. Remember, side B is across from angle B, so this is 12.9. Side C across from angle C is 15.4. And what we have here is a situation of side, angle, side. So what we need to do first is use the law of cosines to figure out the side opposite of the angle that we're given. So we're going to start off by figuring out what this side is here. So I'm going to write down use law of cosines. And for this particular problem, I'm going to set it up as a squared equals b squared plus c squared minus 2bc times the cosine of theta, or in this case, angle A. So if I plug all of my values in, I'm not going to write all that down, I'm sure we can do that. A squared, again, after I plug in the b, the c, the b, the c again, and the angle A, make sure you're in degree mode. You should get 109.7. But then remember, we need to take the square root of that, so A ends up being approximately 10.5 meters. So now from here, we can do it a couple different ways. We can figure out what B is, or we can figure out what C is. It really doesn't matter what order we go in. I'm going to use the law of cosines to figure out both of them. So I'm going to start out by finding out what angle B is. I set it up like this. Okay, bear with me. 12.9 divided by the sine of B equals 10.5 divided by the angle across from it, so the sine of 42.3. So if we go ahead and cross multiply, those two values, and then go ahead and divide, we should get the sine of b we should get sine of b is equal to 0.827. Again, make sure you're in degree mode when you're doing this. Now, in order to solve this, in order to figure out what angle b is, you take the sine inverse of both sides. So really what we get is b equals the sine inverse of 0.827. And that gives us the final answer for b of 55.8 degrees. And now we know that all of the angles in a triangle have to sum up to 180 degrees. So I'm going to take the two angles that we were given, angle A, angle B. I want to add them together, then I'm going to subtract them from 180. If I add 42.3 plus 55.8 and subtract it from 180, we get a remaining angle C is equal to 81.9 degrees.